we're going to use the substitution method to solve this system of equations. Now, the substitution method is basically what it says. We're going to substitute. So what you do is you look for an x or a y by itself. That means I'm looking for a 1x or a 1y. Well, here's a 1y right there. So I'm going to solve for y. So I'm going to write 2x plus y equals 8. Now I want to get y by itself because that's what I'm going to substitute back in. But we're going to keep working at it here. I'm going to subtract 2x from both sides of the equal sign. So y equals negative 2x plus 8. Now that we know what y is, we're going to substitute that back into the second equation. Now we can't substitute it into the first equation because this actually is the first equation. So I'm going to write the second equation out, 3x minus 2, and a big parentheses where the y goes, equals negative 2. The reason is y is negative 2x plus 8. Negative 2x plus 8. So now I'm simply going to do some algebra to get x by itself, or solve for x. So 3x is here. I'm going to take negative 2 and distribute it through everything in the parentheses. Negative 2 times negative 2x is plus 4x. Negative 2 times 8 is negative 16 equals negative 2. Now I'm going to collect like terms. So 3x plus 4x is 7x minus 16 equals negative 2. Now I want to get 7x by itself, so I'm going to add 16 to both sides of the equal sign. Remember, we have to keep it balanced. So I'm going to get 7x equals, now negative 2 plus 16 is 14. Divide by 7 to get x by itself, and I get x equal to 2. Now to figure out what y is, I can either use the first equation or the second equation, or I could go right back here and use this because we know what y equals. It's really up to you. Let's use this shortcut though. We know that y equals negative 2x plus 8. We also happen to know what x is. X is 2. So y equals negative 2 times 2 plus 8. So y equals negative 4 plus 8. And negative 4 plus 8 is 4. Well, let's check to make sure that works. I can use either of my first equations to check. Let's use the first one. 2x plus y equals 8. Now I'm using my first equation. Now I'm going to substitute in my x, which happens to be 2, plus my y, which we got to be 4. I was looking around here, but there it is. 4 equals 8. 2 times 2 is 4, plus 4 equals 8, and that's correct. So we must have done it right. Now to write my solution, I'm going to write 2, 4 as an ordered pair. Let's solve this system using the substitution method. Now the substitution method is exactly what it says. We're going to substitute. So what I'm looking for is a 1x or a 1y. Now when I look at these, I don't have a 1x or a 1y, so I'm going to have to make it. Now it doesn't matter which equation or which letter I'm going to solve for. But how about I pick this one, and let's just solve for y. So I have 5x minus 2y equals 4. Now I'm going to solve for y. So I'm going to subtract 5x from both sides of the equal sign. I could have solved for y. I just chose not to. So negative 2y equals negative 5x plus 4. Now I want to get y by itself, so I have to divide each part by negative 2. So that gives me y equals a negative divided by a negative is a positive. Positive 5 halves x. 4 divided by negative 2 is negative 2. So this is what y is. Since I used the first equation to solve for y, I'm going to put y right in there. Okay? Remember, this is actually the first equation. So I'm going to write it out. 2x minus 2 times y equals 3. Well, y is 5 halves x minus 2. So we're going to put that in there. 5 halves x minus 2. Now it's a matter of doing algebra. I'm going to distribute my negative 2 through So I'm going to have 2x, negative 2 times 5 halves. I'm going to do that on the side here. Negative 2, which is over 1, times 5 over 2 is, we multiply straight across, negative 10 halves, which reduces to negative 5. So negative 2 times 5 halves x is minus 5x. Negative 2 times negative 2 is a plus 4, and that will equal 3. Now I'm going to collect my like terms. 2x minus 5x is negative 3x plus 4 equals 3. I'm going to subtract 4 from both sides of the equal sign. So negative 3x equals negative 1. Now I need to get x by itself, so I need to divide by negative 3. So it looks like I'm getting negative x to equal, now negative divided by negative is a positive, so x equals positive 1/3. Well, don't worry that you get a fraction, okay? So since we know what x is, I need to find y. Well, I can either put it into my first equation, my second equation, or I can put it into this guy, since I already have y by itself. So let's do that. Y equals 5 halves times x, which is 1/3, minus 2. Now I'm just taking this equation and substituting x in there. So y equals 5 halves times 1/3, you multiply straight across, gives you 5/6 minus 2. Now remember, 2 is over 1. Also remember, we need a common denominator. So our common denominator is going to be 6. So I'm going to multiply by 6 on the top and 6 on the bottom. So what I'm going to get is 5/6 minus 2 times 6 is 12. 1 times 6 is 6. 5 minus 12 is negative 7/6. So I get y to equal negative 7/6. Now let's see if that's going to work. Let's see if that's true. I can use either of my equations to prove it. Let's use the second one. Since I'm running out a little bit of room, I'm going to write it over here on the left side. So it's 2x minus 2y equals 3. Now x we decided, we hope, is 1/3, minus 2 times y, which we decided is negative 7/6, and hopefully that will equal 3. Okay. So this is over 1. 2 over 1 times 1 over 3 is 2/3. A negative times a negative is a positive. This is also 2 over 1. 2 times 7 is 14 over 6. And we're hoping it's going to equal 3. Okay, I made my marker a little bit darker for you. We need a common denominator, which will be 6. I could have reduced this, but I chose not to. 2 times 2 is 4. 3 times 2 is 6. Plus 14 over 6. Now hopefully that's going to equal 3. 4 plus 14 is 18 over 6. And 18 over 6 equals 3. So we must have done it right. So I'm going to write my answer way over here. I'm going to write it as an ordered pair. My x value is 1/3, and my y value is negative 7/6. Now remember, that means that if I graphed my two equations, this is where they would intersect at.